Welcome friends. An earthen dam is a non-rigid type of dam which is constructed of earth material. We know seepage through an earthen dam is always there. Here I am going to discuss about Phreatic line and Fellenius line in homogeneous type of earthen dam. Actually these two lines differ in their meanings as well as their uses. However, these two lines are important for the design and slope stability of earthen dam. Therefore, a short description of these two lines is presented over here. A seepage line is the line at the upper surface of the seepage flow at which the pressure is atmospheric, or it is the line above which there is no hydrostatic pressure but below which there is positive hydrostatic pressure. Phreatic line forms the upper boundary of the flow net. The flow net is constructed of streamlines and equipotential lines. Above the phreatic line, the soil is dry and below it is submerged. The diagram shows an earthen dam of height h. A drainage filter is provided there. As we know, phreatic line follows a parabolic shape which is constructed and shown as AIC in the diagram. Curve AIC represents the base parabola. The coordinate points of phreatic line can be determined by either graphical method or analytical method. The curve BIC indicates the phreatic line. The seepage in the dam body starts on upstream face. The point B, which indicates the highest water level point in contact with upstream face of the dam. Hence, the phreatic line starts at point B and follows a curved path BIC. Below this curved path BIC, that is phreatic line, a grid of streamlines and equipotential lines is drawn which represents a flow net. The purpose is to locate the phreatic line in earthen dam are to mark top flow lines so that flow net can be drawn to determine the quantity of seepage and the pore water pressure. To ensure that the phreatic line does not intersect the downstream face of the dam and cause its softening and consequently failure of the downstream face. To mark the dividing line between dry soil and saturated soil so that the corresponding unit weights can be determined for the stability analysis. An earth embankment fails due to sliding of a large soil mass along a curved surface, that is an arc. The method used to examine the stability of slopes is the Swedish slip circle method or slices method. In slope stability analysis, behavior of cylindrical soil mass is studied. For such a cylindrical soil mass, a failure arc can be assumed. It is assumed on both upstream as well as downstream sides of the dam. In this diagram, such a possible failure arc whose center is O is considered. It is assumed to be possible failure arc as we don't exactly know whether it leads to failure or not, which can be tested by finding the factor of safety for the arc. For the study and finding factor of safety, the earth mass in the failure arc is divided into a number of equally spaced segments, vertical segments, which are called as slices. These slices are in general 6 to 12 in number. Let R be the radius of the arc and B is the width of each segment. For each of the segments, the weight of the soil mass in the segment is determined. Let they may be W1, W2, W3, etc. for slice numbers 1, 2, 3, etc. From the weight of each slice, a normal and tangential component is determined. From the normal and tangential components, the factor of safety is determined for each possible failure arc. Here, the tangential component is given by weight component times sine of theta, while normal component is given by weight component times cos of theta. If the factor of safety is within safe limit, say less than 1.5, the assumed slip arc is considered to be safe. If it is beyond the safe limit, then the possible slip arc is unsafe and there may be failure occurring at this level. But in order to identify the failure arcs, a number of possible arcs need to be studied. The respective centers of arcs may lie anywhere as shown in this diagram. The arcs may be A1, B1, A2, B2, A3, B3, etc. with their centers at O1, O2, O3 respectively. Now, in order to reduce the trials of searching of centers of possible failure arcs, a Fellenius line is drawn on upstream as well as downstream face. Here it is assumed that the center of critical slip arc lies on the Fellenius line. A Fellenius line can be drawn by joining 2 points P and Q. Point P is obtained by intersection of lines BP and AP drawn at points B and A of the face of the dam. At point A, line AP is drawn at an angle of alpha with respect to inclined face of the dam, while at point B, line BP is drawn at an angle of beta with respect to horizontal at B. The angles alpha and beta depend on the slope of the face. For intermediate slopes, the interpolation of the values of alpha and beta can be done. A point Q is located with its coordinates h and 4.5 h with respect to point A at the extreme end point of sloping face of the dam. Here h is the total height of the dam. After joining points P and Q, Fellenius line is obtained. The center of most critical circle may lie anywhere on the line PQ or its extension. This line is called as the Fellenius line. However, its exact position can be obtained only after conducting the stability analysis for different slip surfaces. That is, after finding out the factor of safety values for different slip circles or slip surfaces. For different possible failure arcs with their centers at O1, O2, O3, etc. on the Fellenius line, respective factor of safeties are determined as F1, F2, F3. Among these factor of safeties, the least factor of safety must lie within the safe limit. A locus of factor of safety of these different centers of failure arcs is drawn. The slip arc with least factor of safety is said to be the most critical arc or critical circle. I hope you will get an idea of Phreatic line and Fellenius line in Earthen Dam. Thank you.